you spoke about the spectra here. Whenever you spoke about the spectra, so you have to please move the window away to shade of question. Are you getting? So in this atomic spectra, what is the message we are getting? Yeah. Are you able to hear my voice? Babu, inpistunda Babu? Kritika, Kumar, Pravina, Priyanka. Hello? Can you hear my voice? If you say yes, we can proceed.
Yes, sir.
So whatever I am saying, sharing the screen, are you able to see that? Is it?
Sir.
Kanpistunda నేను షేర్ చేసిన screen?
కనిపిస్తుంది.
Yeah, okay then. So in this block 1's atomic spectra, we are to be discuss in this hydrogen spectra. So that what do you mean by spectra means here, whenever such a frequency or wavelength of the light which is to be incidenting upon any particle, so that the particle which is going to be absorbing such energy, or else it is to be emitting such energy, which should be seen in the form of here lines which is indicating here a spectra. That means a different frequencies, different wavelength which is to be emitted. Okay, the particle or atom or whatever it may be. So that that is looking like in the form of 7 colors. That means here violet, violet, indigo, blue, red, like that. Okay, now. So here also we are to be talking about the hydrogen spectra. So that in this hydrogen spectra, H alpha, H beta, H gamma. Okay, line spectra you will get here. Okay, so that to be discussed in this atomic spectra. Molecular spectra is also there. So that we have to talk about the how the molecules which are to be here behave like this. So when the light is to be a energy which is to be emitting upon the molecular here, what type of spectra you are to be getting here. Okay, but also electromagnetic spectra, we have to talk about that. What is electromagnetic spectra? So the electromagnetic spectra, which includes here radio waves, microwaves, infrared, visible, ultraviolet, X-rays, gamma rays, like that here. The frequency range which should be 10 power 4 to 10 power 24 range, which is to be here takes place here. When you talk about this frequency, the reciprocal of the frequency, which is nothing but here a wavelength here, that is also to be discussed. Okay, Nandi? మీకు ఏమైనా అర్థం కాకపోతే ఇన్ డీటెయిల్ గా చెప్తాను మీకు. యూ నీడ్ నాట్ బి వరీ అబౌట్ దిస్. If you are unable to understand the English language, we will transfer it to your Telugu language also. No need to be worried here. Okay, next is that block 2. In block 2, elements of quantum mechanics. Okay, so first of all we have to talk about the classical mechanics. So the classical mechanics which should be talked about the here, there should be a large particle is there. There should be the size of the particle is a large one. Okay, the energy is also more. But whenever you spoke about the quantum mechanics, the energy which is to be splitting into a particles, that should be transferred, which is in the form of waves. Okay, so that is related to the quantum mechanics. Before discussing the concept of the elements of the quantum mechanics, let you know about the what is the classical mechanics, what is the quantum mechanics. If you are going to be comparing, if you are going to be here distinguish between these two, then only you can able to understand this concept here. So in this block 2, you can have 3 units. So one is that the photoelectric effect and also matter waves. Definitely one question is going to be giving out. So in one first unit is also here different types of spectra, hydrogen spectra, about the hydrogen spectra, Bohr's postulates. Damn sure essay question is to be asking to you. Okay. So in this unit 3 photoelectric effect, what is photoelectric effect? So who proposed this theory? Einstein proposed 1905. Whenever such a frequency or a wavelength or intensity of a light which is to be incidenting on a metallic plate, the plate which is to be emitting such a energy. Okay. So that means the a plate which is to be emitting such a electrons. That means those electrons which is nothing but a photoelectrons. Okay. So that is to be depending upon the intensity and also here a frequency or also the reciprocal of the frequency wavelength also. So that is to be related here photoelectric effect, and also you have to derive the equation for the work function. And later on we have to talk about the matter waves. Okay, matter waves. We are to be talking about the matter. Whenever you spoke about the matter, something is there. That means which is related to such a here mass and energy. That is related to de Broglie's lambda equals to h by p or h by mv. That is to be discussed later on. Schrodinger wave equations. So in this Schrodinger wave equation, Schrodinger time dependent wave equation, time independent wave equation, there are such applications, good applications are there. What are those? One dimensional particle, two dimensional particle, as well as the three dimensional particle. Okay. So we have to implementing this Schrodinger time or time dependent wave equations. We are to be implementing to the one dimensional box, two dimensional box, three dimensional box. Okay. Damn sure essay question. Block 2 is very, very important here. Later on in block 3 nuclear physics. Okay. That is a nuclear structure. So here you have to talk about the nuclear here. Whenever you spoke about the matter consists of the particles or atoms, whatever it may be. Atoms which is consist of a nucleus. That means here you have to spoke about that where the mass of the atom is totally or entire mass which is to be situated at a point, that is nothing but here a nucleus. Nucleus consists of the nucleons. Nucleons means protons and neutrons. Okay. Around the nucleus in different orbit, the electron which is to be revolving in different orbits. Okay. The charge of the electron is negative and the charge of the proton is here positive and the chargeless particle is neutron. So you have to spoke about that there is an objective type of bits which is to be asking to you when you are going to be facing writing the competitive examinations like group 1 or group 2 or SSC staff selection commission or RRB railway recruitment board. Okay, now like that there are so many competitive examinations are there. They are going to be asking them what is the charge of an electron? 1.602 into 10 power minus 19 coulombs here. Okay. So proton is also same, but the thing is that only this is plus and that is minus. So what is the charge of the nucleus here? Positive. Why? Because of here chargeless particle as well as the proton charge. That is a plus minus plus 0. That is nothing but a positive. That's what here. Always the charge of the nucleus is a positive here. So there is a that is to be related here. What is a natural radioactivity? We have to talk about the radioactivity and who found this radioactivity, Madam Curie. Okay. So here you have to talk about that what are the radioactive elements here. Okay, now. So here what is half-life, what is mean life, and what is radioactivity definition. Okay. So we have to talk about in this case unit 6 and transportation of elements here. So many different types of elements are there. So we have to talk about short question, definite short question, which is to be given to you from unit 7. Later on, we have to talk about the radiation detectors here. Okay, radiation detectors. Whenever what is mean by radiation with respect to the thermal radiation, that means in the case of thermodynamics, we have to talk about the quantum theory of radiation. There only we are to be discussing that what is the radiation. If I am going to be speaking here, you are to be listening there through the one instrument, that is here you and me. There is a media which is to be acting upon. The media is nothing but a air, so that through the media the sound which can pass in from one to another place. Okay, now. But whereas in the case of the energy which is to be transferring from the one place to the another place, it doesn't require any media at all, then that is related to the radiation here. Ardhavathundandi? Vikiranamo. So the energy of the radiation E equals to h nu. Who proposed this? Max Planck. E is the energy which is emitted or absorbed by this photon, and also h is the Planck's constant, 6.602 into 10 power minus 34 joules second, and also nu is the frequency. Okay, so that is to be noted here. And radiation detectors here, there are scintillation and also GM counter, proportional counter. Okay, so different types of counters are there. So how the radiation which is to be detected here out of in radiation detectors, definitely one question is to be asking here. And later on, artificial radioactivity. There may be a short question is to be giving to you from this artificial radioactivity. Next, last block 4 is that here properties of nuclei. What are the here properties which should be including here a nuclei? What are the nuclear models are there? So, and also here what is nuclear fission and nuclear fusion is there. So what is the difference between the fusion and fission here? And you have to talk about the here nuclear chamber here, and also finally we have to talk about the elementary particles. Okay, so one question is to be giving to you from this. So this is about our syllabus here. So in block 1 we have to go for the spectroscopy. Wait a minute. Yeah, in the case of spectroscopy, first one is that Bohr's theory and line spectra. Okay, not a line spectro, which is a line spectra. That means which is related to the hydrogen spectra. So what is a line spectra? We have to talk about. So in this year, so we have to give the introduction portion about the Bohr's theory and what is a line spectra, what is Sommerfeld proposed this, and how the energy levels of hydrogen atom. Okay, so the question is to be asking like you have to expand the energy levels of the hydrogen atom, or else you have to discuss about the vector atomic model, vector atom model. So out of 1.5 and 1.6, most important in examination point of view. Okay, now finally another experiment is there, Frank edge experiment. Okay, so here we have to talk about the here the distribution of energy in a continuous spectra. We are not to be talking about the here a line spectra. Continuous spectra means continuously the energy which is to be emitting or absorbing here. So that the continuous spectra of a black body, which could not be explained about the classical theories, which was proposed by the here Max Planck, and which is a revolutionary concept about the here radiation quanta. That means E equals to h nu, whatever the energy which is to be transferable. So then the energy which is not in a continuous manner, the energy which is in a discrete manner, that means the energy which should be dividing into a small packets, the packet energy which is nothing but E equals to h nu, that packet which you can call it as a quanta. What do you say? Quanta. Okay, so that's what here you have to be focused on. What is quanta? Who proposed this? Max Planck. Okay, now. So, and also here in the beginning, you have to talk about that this is not in a discrete manner, which is always, which is in a continuous, but which regards to the line spectra of atoms as well as the molecules here. And also the wavelength which is related to the here a line spectra, that means you have to talk about the frequencies or else a wavelength here. Okay, So here, what is the origin of the characteristics of a light spectra? Which should be due to the some fundamental mechanism which is common for the all atoms as well as the molecules. Here, if you are to be considering here a hydrogen, what is the atomic number? Hydrogen 1. That means 1s1. Okay. So here the line spectra due to the hydrogen, which should be studied extensively as well as the here there is some development regarding the structure of the hydrogen atom here, and which led to the Bohr in 1913. He proposed the theory related to the atomic spectra, atomic structure here, and in this there are some empirical laws which is to be used here, and to discuss about the spectral series. What are those? The spectral series: line, Balmer, passion, bracket, fund. So these are the series which are related to the hydrogen atom, so that whenever such an energy or a radiation which is to be absorbed by the hydrogen atom, the hydrogen atom which is to be emitting, or else which is to be give the absorption spectra as well as the emitted spectra, so that which is related to here the thing is that H alpha, H beta, H gamma, H delta. Okay, I will show you the spectrum here. I need not even worry here. So which was Bohr's theory, which is explaining the line spectra due to the hydrogen atom. But what about the more than the here if two atoms are there? So if you to be considering hydrogen, lithium, like that, which is not explained successfully. So that we have to study about the vector atomic model, so that which can determine the critical potentials here. So what is a line spectra? See here, are you able to see this? So that this is a source here. Okay. So the source which is to be prism here, the source which is a light source is a light here, a monochromatic a light which is to be here incidenting upon the prism here, the prism which is to be splitting the white light into a 7 colors. Getting my point? That means this is nothing but when the white light which is to be splitting into the 7 colors, that is nothing but a dispersive power of the prism. So I think so you have been already studied in the second year, and also you done an experiment, dispersive power of a prism, in your laboratory. I think so. Do you observe the spectra there? Babu, experiment chesnara? Pujita, Priyanka, Vijay, have you done the experiment? Huh?
Sorry.
Experiment chesarama? Dispersive power of a prism.
No, sir.
చేయలేదా? ప్రిజం ఉంటుంది, ప్రిజం మీద ఏమో వైట్ లైట్ ఫాల్ అవుతే మీరు స్పెక్ట్రోమీటర్ ద్వారా అబ్జర్వ్ చేసినప్పుడు మీకు స్పెక్ట్రమ్ కనిపిస్తుంది కదా. హ్యావ్ యు సీన్ దట్?
Yes, sir. Yes.
మరి నో అంటారే అమ్మా. సో
ప్రాక్టికల్ గా చేయలేదు అంటున్నాం సార్.
అమ్మా
ప్రాక్టికల్ గా చేయలేదు అంటున్నాం.
ప్రాక్టికల్ గా చేయలేదా? దెన్ వేర్ డు యు అబ్జర్వ్ దట్? ఒక్క నిమిషం ఆగండి. ఐ జస్ట్ వాంట్ టు షో యూ. రైట్ అండి. So that whenever a white light which is to be incidenting upon a prism here, so there you can able to desktop files, boards. another one I am sharing here. ఎందు గురించి అంటే మీకు లైన్ స్పెక్ట్రా ఏందో ఒకసారి చూపిస్తాను. So this is about the Bohr's atomic model here. So are you able to see this? ఏమో కనిపిస్తుందా?
Yes, sir.
ఏం కనిపిస్తుంది బాబు? Bohr's atomic model అయినా?
Bohr's atomic model.
Right. So see here. So a Bohr which he developed before discussing the line spectra గురించి మనం మాట్లాడినప్పుడు ఇది ఒక్కసారి చూద్దాం here. So here which is a theory of the atomic structure here, and also which is the two essential features which was considered from the Rutherford's planetary model here. So here you know pretty well, just now we discussed about that the atom consists of a central portion that is called here nucleus. That means what is that nucleus here? Where the mass of the atom which is situated at a point, that point which is nothing but a nucleus here. So that the nucleus which includes, what do you say? Nucleus which includes here nucleons. What are those? Protons as well as the here neutrons. So that's what here you can able to see here. This is a atom here, a Bohr's atomic model with teeny nucleus with electrons revolving in concentric orbits here. So blue spot which is indicating a nucleus. Around the nucleus, the electron which is to be revolving in different orbits. Red anta kuda electron chupistunnaru. So this is the first orbit, and this is the second orbit, this is the third orbit. Okay, so first orbit means K and second orbit is L. Avuna kada? If n equals to 1, that is related to K, and if n equals to 2, that is related to L, n3 M. But what is the maximum possibility of the electrons which can be occupied in a shell? Shell maximum electron possibility enti formula 2n square. What is that formula? 2n square. So if you substitute 2 into 1 is related to the K shell. Okay, yes. 2 1 square means 2 into 1 is nothing but a 2. So that in K shell, how many number of electrons which can be occupied? 2.
2 electrons.
Are you able to see this? This is the K shell, first electron and second electron.
Second electron.
Ardhamautunda babu cheppedi?
Okay sir.
If n equals to 2 into 2 square.
For 8 electrons.
2 2s are 4, 4 2s are 8. Count here.
8.
1 2 3 4 5 6 7 8. So the maximum number of electrons which can be accumulated in L shell, which is 8. Okay, na? That's why if you want to write it down, the K shell, the electronic configuration is 1s2. Okay, 1 is related to the K shell, and S is an orbit which can accumulate 2 electrons. Getting my point? Similarly, L cell is 8 electrons. Mari 8 electrons etla sir ante 8 electrons చూడండి 8 electrons ఎట్లా బాబు 1 2 3 4 5 6 7 8 electrons. So the 8 electrons which is related to, if n equals to 2, that is related to L can accumulate 8 electrons. So what is the configuration here? 1s2, that L equals to 2 na, 2s2 2p6. అర్థమవుతుందా బాబు? n2 కదా బాబు, n2 in L shell. So these are the subshells, S and P are the subshells. So S which can accumulate maximum number of electrons is 2, and P which can accumulate 6 electrons. So that 2 plus 6 is 8 electrons. Similarly, if n equals to 3, 3 3s are 9, 9 2s are 18 electrons. You can count it here, 18 electrons are to be there. So that 3s2 3p6 3d10. Getting my point? 3s2 3d6 3d10. Total is 10 plus 6 plus 2.
18.
18. 18 should be there
18.
here. Getting my
Yes.
point? This is K, L, M,
Yeah.
N, like that. Is it clear now?
Yes.
Yeah. So this is about the first point. The central portion is a nucleus here. And also the electrons which is to be revolving around the nucleus in a circular orbit. And also there should be a centrifugal force which is to be balancing here. Okay. So that here what is the net electrostatic attraction? Electrostatic attraction means nucleus is having a positive
Nucleus.
charge. Around the nucleus, electron is revolving in different orbits. The charge of the electron is negative here. So that nucleus is a positive and the electron is a negative. So between the positive to the negative, what type of attraction should take place? Electrostatic attraction, which is to be takes place. So that is about the second point you have to project. So you can see here what is the orbit of the atom here. N equals to 1 K shell, 2 is L shell, N equals to 3 M shell. Okay. And also here, according to the Planck's quantum theory of radiation, so Bohr made such a assumptions here. You should write it down. Definitely you have to write it down. Otherwise, the examiner is not going to give the marks to you. So what is that here? He assumed an electron, okay, and also whatever the field of the nucleus, which is not capable to moving along each path. There is a possible on the basis of classical theory, but the electron can move along one discrete set of allowed paths, not in a continuous manner. The electron can path or move along the discrete set of allowed paths. So that these paths or the orbits are possible for the orbital angular momentum of the electron, which is always
Integral
equal to the
multiple
integral
of
multiple of the h by 2 pi, where h is the Planck's constant here. And also here, when the electron which is to be revolving with such a velocity, and you have to say that there should be a momentum. That momentum is mass into velocity. That is nothing but here mv. And the nucleus which is to be the electron which is to be revolving in such a orbit here. What is that here? The momentum of the electron is mvr. So that mvr which is equals to nh by 2 pi. If we are going to be substituting n when n equals to 1, that is related to the first orbit. N equals to 2, second orbit, like that. Okay.
Third orbit.
And the next one is that no energy which is to be radiated, okay, by the electron, as long as it remains in its definite or stationary orbits, then which can permitted the orbits are non-radiating paths. Okay. So here you can see that here how the radiation which should takes place when the electron which is to be jumping, electron ekkadi nunchi jump chestundi babu, higher orbit nunchi lower orbit ki. That means higher to the lower orbit, the electron which is to be jumping, whenever it is to be jumping, you need to say that the electron which is to be losing such energy, that energy which is to be released in the form of here photon. So that delta equals to E2 minus E1, that should be equal to negative h nu. Why do you say negative, which is losing the energy here? Okay, now, which is losing the energy. That's why here you have to write it down negative h nu. So that's what here, how the energy which is to be increasing from the nucleus to the, in this direction, upward direction, the energy which is to be increases, but whereas the photon which is to be coming down from the higher to the lower, there only there should be a loss of energy, which is to be emitting the energy. When the emitting is to be takes place here, you need to be writing down that here energy is losing, and there only the photon is to be released here. That is in the form of E equals to h nu. Could you able to see this here? Is it okay?
Okay.
Next. But when absorbing means, yeah, this is a positive. See here between the two figures, from the upper to the lower. But here, electron which can jump from the lower to the higher. If it is to the lower to the higher, there only it is to be absorbing such energy, that is in the form of E equals to h.
E2 minus E1.
Yeah. Okay, na? That's why here in starting I already told you that here when the electron which is to be jumping, that means there should be a absorption is also to be takes place, and as well as the here emission is also to be taken. We need to understand that what is the concept which is to be involving in this. Is it clear now? So that what is the here the difference of energies in the radiation which is to be giving out here E2 minus E1 equals to okay, E2 minus E1 you need to say that the delta E. Yeah. This is about the spectra. ఒక్క నిమిషం స్పెక్ట్రా గురించి మాట్లాడతాను నేను. Yeah, this is the case. మీకు అంతకు ముందు చెప్పినాం కదా బాబు లైన్ స్పెక్ట్రా గురించి.
లైన్ స్పెక్ట్రమ్ సార్.
లైన్ స్పెక్ట్రాలో నీకు ఒక బొమ్మ చూపించినాం కదా.
దిస్
ఇస్ ద వైట్ లైట్ హియర్. మీకు క్లియర్ గా చూపిస్తున్నా చూడండి.
ఓకే.
మీకు ఇది టెక్స్ట్ బుక్ లో ఉండదు. నేను ఆల్రెడీ ప్రిపేర్ చేసినటువంటి పీపీటీ ఇది.
అవును సార్. టెక్స్ట్ బుక్ లో షార్ప్ ఉంది సార్.
టెక్స్ట్ బుక్ లో బ్లాక్ గా ఉంటది. అందులో ఎంత క్లియరిటీగా ఇవ్వడు మీకు. See here, you can easily observe that this is the white light source. White light అంటే ఏంటి? Which includes the 7 colors. Okay na? So which is this white light which is passing through the hydrogen sample. Hydrogen sample ద్వారా light pass అవుతుంటే ఏమవుతుంది బాబు? Hydrogen sample which is to be absorbed this light.
White light.
And also which is passing through this slit. What is the use of this slit here? Slit wall ద్వారా పోతుంటే ఏం చేస్తున్నాం మనం ఇక్కడ? The light which is to be falling in only one direction. And also you are to be increasing the intensity of the light. Okay? ఈ లైట్ దేని మీద పడుతుంది ఇక్కడ? The white light which is to be incidenting. White light includes the hydrogen sample. This light which is to be incidenting upon a prism here. So that this white light which should be divided into these many colors. So what type of which is a hydrogen spectra? So there also a detector. If you are going to be seeing or observing through the spectrometer, you can easily observe that here different what do you say here wavelengths are there, so that you can easily see that here black unnadi, ikkada manaki purple unnadi, indigo, green, orange, yellow, red, like that. Okay na? So this is about the one thing here. This is a absorbed. Okay na? Absorption spectra ఇది. Absorption ఎనర్జీని అబ్జార్బ్ చేసుకుని స్పెక్ట్రాని ఇస్తుంది. మరి ఎమిషన్ స్పెక్ట్రా ఎట్లా ఉంటుంది చూడండి. అబ్జార్ప్షన్ స్పెక్ట్రాలో ఏమో మనకి అంత క్లియర్ గా కనిపించదు. ఎమిషన్ లో చూడండి, when the hydrogen is exciting means higher to the lower level, the energy which is to be here released, there should be excitation is to be takes place here. So here this light which is to be incidenting upon the prism, then there should be a line spectra. Could you able to see this? ఇప్పుడు చదివిన దానికి లైన్ స్పెక్ట్రా అంటే ఏంటో చూసినారా? అబ్జార్ప్షన్ స్పెక్ట్రా అయితే మనకి ఏ విధమైనటువంటి గీతలు కరెక్ట్ కలర్ కి సంబంధించిన ఏమి లేవు. అదే లైన్ స్పెక్ట్రాలో చూడండి, లైన్ స్పెక్ట్రా విచ్ షుడ్ టేక్స్ ప్లేస్ ఇన్ ది కేస్ ఆఫ్ ఎమిషన్. ఎమిషన్ లో చూడండి పర్పుల్ లైన్ ఉన్నది, ఇక్కడ మనకి బ్లూ లైన్ ఉన్నది, ఇక్కడ ఏమో రెడ్ లైన్ ఉన్నది. గెటింగ్ మై పాయింట్? ఓకేనా? లైన్ స్పెక్ట్రా డిఫరెంట్ కలర్స్ విచ్ ఇస్ టు బి ఎమిటింగ్. మరి ఇక్కడ లైన్స్ ఉన్నాయా? కంప్లీట్ కలర్స్ ఏ ఉన్నది, ఎంటైర్ డిఫరెంట్ కలర్స్ ఉన్నాయి. దేర్ ఇస్ నో లైన్ స్పెక్ట్రా విచ్ ఇస్ టు బి గివింగ్ అవుట్.
మిస్సింగ్ వేవ్లెంగ్త్ సార్.
ఎమిషన్ లో మాత్రమే నీకు ఇక్కడ లైన్ స్పెక్ట్రా ఇస్తుంది. ఇస్ ఇట్ క్లియర్? హైడ్రోజన్ స్పెక్ట్రా చూడండి, చూడండి. గెటింగ్ మై పాయింట్? దీస్ ఆర్ ది లైన్ స్పెక్ట్రా. ఓకే, ఎమిషన్ లో మాత్రమే ఆ పాసిబిలిటీ. చూడండి, దిస్ ఇస్ ద లైమన్ సిరీస్, బామర్, ప్యాషన్, బ్రాకెట్, ఫండ్, పుండ్స్. సో దీస్ ఆర్ ది డిఫరెంట్ spectra which is related to the hydrogen. So this is a line spectra, not in a continuous ga ekkadaina unda. There should be here different wavelengths which is to be emitted by this. Okay, so here what is the Lyman series, what is the Balmer series, what is the Passion, bracket, Fund, Punds. Okay, so these are the different spectral series which should be observed, and where these spectra which is to be observed, that should be here Lyman series always which should be observed in the case of ultraviolet region, Balmer series visible region, Passion bracket
series
is always
infrared.
in infrared regions.
Okay.
Okay. So what is the
Okay.
Rydberg's? So these are the case. You have to draw these figures. Okay, now. So here, what is the energy level of the hydrogen when n equals to infinity? Most important bit minus 13.6 electron volts. Okay, most important bit is objective bit. So this is about the here spectra. N equals to 1 అయితే ఎంత వేవ్ లెంత్ తోటి మనకి స్పెక్ట్రా ఇస్తుంది, ఏ సిరీస్ ఇస్తుంది, మాక్సిమం నుంచి మినిమం రేంజ్ ఎంత వరకు ఇస్తుంది, లైమన్ సిరీస్ ఎక్కడి నుంచి ఎక్కడి వరకు ఉంటుంది, 122 నానోమీటర్స్ 10⁻⁹ నుంచి 94 నానోమీటర్స్. nm అంటే నానోమీటర్స్. ఓకే, ఇఫ్ n equals to 2 means L is related to Balmer series. Balmer series ఎక్కడి నుంచి ఎక్కడి వరకు ఉంటుంది, 656 నానోమీటర్ నుంచి 410 నానోమీటర్స్ వరకు ఉంటుంది. యా, m వచ్చినప్పటికి చూడండి సిరీస్ లోకి వచ్చినప్పటికి లైక్ దట్ యూ హ్యావ్ టు అబ్జర్వ్ దట్. ఓకేనండి. సో వాట్ ఆర్ ద లిమిటేషన్స్ ఆఫ్ ది బోర్ థియరీ? లిమిటేషన్స్ ఏంటి, ఎందు గురించి ఫెయిల్ అయింది బోర్స్ థియరీ అంటే ఓన్లీ హైడ్రోజన్ స్పెక్ట్రా గురించి మాత్రమే ఇట్ ఈస్ టు బి ఎక్స్ప్లైనింగ్. అండ్ మోర్ దాన్ ది వన్ ఆటమ్ కంటే ఎక్కువ, వన్ ఆటమ్ ఉన్నదంటే మోర్ దాన్ 1 అంటే ఒక ఎలక్ట్రాన్ కంటే ఎక్కువ ఉన్నాయి అనుకోండి, 2 ఎలక్ట్రాన్స్ ఉంటే ఇట్ ఈస్ నీడ్ నాట్, ఇట్ ఈస్ ఫెయిల్ టు ఎక్స్ప్లైన్ about the hydrogen spectra, about the light spectra or whatever it may be here. So it does not explain the spectra of atoms which is more than 1 electron. Okay, electron గురించి ఉన్నప్పుడు మాత్రమే it is to be explained. And also Bohr's atomic model which is failed and account for the effect of the magnetic field apply చేస్తుంటే which is related to the G-man effect. RS electric field apply చేస్తున్నాం అనుకోండి which is related to the Stark effect. Okay, on the spectra of atoms or ions, atoms కావచ్చు లేకపోతే ion కావచ్చు. And also which is to be observed when the source of spectrum which is to be placed in a strong magnetic or electric field. Okay, source of spectrum, ఆ స్పెక్ట్రమ్ ని కనుక మనము ఎలక్ట్రిక్ ఫీల్డ్ లో కానీ మ్యాగ్నెటిక్ ఫీల్డ్ లో కానీ మనం పెట్టినట్టయితే the spectral lines further split into a number of lines. ఓకేనండి. స్పెక్ట్రల్ లైన్స్ మనకి స్పెక్ట్రమ్ వస్తుంది కదా, అగైన్ ఇఫ్ యు ఆర్ గోయింగ్ టు బి ప్లేసింగ్ ద స్పెక్ట్రా ఇన్ అప్లైయింగ్ ది స్ట్రాంగ్ మ్యాగ్నెటిక్ ఫీల్డ్ ఆర్ ఎలక్ట్రిక్ ఫీల్డ్, దేర్ ఆల్సో ద స్పెక్ట్రా which is splitting into a number of lines. And also this observation could not be explained on the basis of the Bohr's model. Later on de Broglie suggested that here electrons like light have a dual character. Electrons which can have a dual character. Okay. That means one time which it should behave like a particle, another which should behave like a wave here. Dual character అంటే ఎలక్ట్రాన్ మాస్ ఉంటుంది, వెలాసిటీ ఉంటుంది, అంటే ఏంటి పార్టికల్ గా మాట్లాడుతున్నాం. అట్లా కాకుండా ఎలక్ట్రాన్ అనేటువంటిది ఒక హయ్యర్ నుంచి లోయర్ గానీ లేకపోతే లోయర్ నుంచి హయ్యర్ గానీ absorption should take place there only which is emitting such a energy that should be in the form of wave. ఓకేనా, ఫోటాన్ రూపంలో ఉంటుంది. అంటే మనకి ఇక్కడ ఈజీగా మన ఫోటాన్ రూపంలో అంటే waves which is to be generating. That means de Broglie, who suggested that? This was suggested by the de Broglie. That means it has a particle as well as the wave characters. So that the Bohr treated electron is only as a particle. Bohr ఏమనుకున్నాడంటే ఎలక్ట్రాన్ అనేటువంటిది ఒక పార్టికల్ మాత్రమే ఊహించినాడు. కానీ de Broglie ఏం చెప్పినాడు, not only a particle which is also behave like a wave here. Okay na? So that is the failure of the Bohr's here. And another objection which is related to the Bohr's theory from the Heisenberg uncertainty principle. Okay, Heisenberg uncertainty principle, what it is to be saying here, the position and momentum which simultaneously you cannot determine. Okay, so that which is related, that means here it is impossible to determine simultaneously the exact position and momentum of the electron. So that here the postulate of the Bohr's, that means here the electron which is to be revolve in well-defined orbits, that means a first orbit, second orbit, like that here around the nucleus and with well-defined velocities does not achievable here. Okay, so these are the failures of the limitations, that means Bohr's theory. So this is the Bohr's one. So we can go back to the another one. Yeah. So చూసినారా బాబు? Okay. Yeah, this is about the line spectra. మనకి చూసిన దానికి దీనికి చూసారా? So this is the source here, a slit is there, prism is there, and photographic plate is there. If you are going to be developing the photographic plate, you can able to observe that what is the spectra it is to be giving out, whether it is a emitting spectra or else a absorption spectra. Emitting spectra, you mean it cannot give the line spectra. Only absorption spectra which is to be giving out. So if you see here, చూసారండి, H alpha, H beta, H gamma, H delta, HS, H infinity. So these are the line spectra. So that H alpha, which is in which should be look like a red. That means maximum 6 to 7,000 angstroms. Okay, that means 1 angstrom equals to 10 power minus 8. Okay, or else you can call it as a 10 power minus 10 meters.
10 meter.
1 angstrom. So print mistake but ikkada chudandi. 1 angstrom is nothing but 10 power minus 8 centimeters or 10 power minus 10 meters. So this is about the visible part of the hydrogen spectra. Kachithanga meer diagram veyali. Without drawing the diagram you cannot able to get this. Okay, 1 minute. So here, what is the Rydberg constant here? The value of the Rydberg constant. I will give you that. Yeah, Bohr's theory. So just now we spoke about the Bohr's theory. The electron is an atom which can move in a circular orbit about the nucleus under the influence of Coulomb attraction between the electron and the nucleus, and also which is to be obeying the classical mechanics laws. And also here the angular momentum of the electron, which is always integral multiple of the h by 2 pi, where h is a Planck's constant. So emission is also going to be takes place. Absorption is also going to be takes place. Which should be considered, which should be here. So you can easily call it as what is the frequency of the radiation which is to be emitted by this electron. That is nothing but here EI minus EF, initial final, divided by H. Okay. ఇందు గురించి ఈక్వేషన్ రాసినాడండి చూడండి. This equation you know pretty well. E equals to delta E equals to here H nu. Okay, right? What is delta E? E2 minus
E1.
E1 divided by H equals to
H.
Nu frequency. Okay, the frequency of radiation emitted by this formula. Frequency nu equals to E2 minus E1 by H. Is it clear?
Yes.
Yeah. So this is about the here equation part. Bohr's atomic theory గురించి మనం ఈక్వేషన్ గురించి మనం మాట్లాడినప్పుడు we should discuss only 2 minutes are left out. So we'll discuss in tomorrow's class. Both done with you can see here what is the energy level of diagram of hydrogen atom. Okay, just now ఇదంతా కూడా మీకు కలర్ లో చూపించినాను.
అవును సార్.
Yeah. What is the Homer fields theory? That is also to be discussed. Okay.
Okay, sir.
If you have regarding any doubts regarding this subject, you can call me at any time. Okay.
Okay, sir. Thank you.
Right. All the best.
Okay, sir.
Same time tomorrow and day after tomorrow.
Okay, sir. Thank you.